It's in our car batteries, it helps grow our food, and it's even used as a benchmark for a nation's industrial strength. Today on The Explainer, we're profiling one of the most important and powerful substances on Earth, sulfuric acid.
Yeah, in a lot of industries, people call it the king of chemicals. And you know what? That's not just some fancy nickname. There is literally no other manufactured compound that's used by so many key industries. So in this explainer, we're going to find out exactly why it earned that crown.
So its chemical formula is H₂SO₄. And for centuries, this stuff, this thick, kind of oily liquid, has been a total cornerstone of chemistry. It actually got its old-timey name, oil of vitriol, because way back when, chemists first got it by distilling these things called green vitriol crystals. So what's the deal? What gives this one simple-looking liquid its royal status and this immense power in our world? Well, to really get it, we need to look at two things: how it's made and what it can do. Okay, here's our game plan. We'll start with how it's made on an industrial scale. Then, we'll dive into its fascinating split personality. After that, we'll check out its special powers. And finally, we'll see just how far its kingdom really stretches. All right, first up, forging the king. You know, every monarch needs an origin story, and for sulfuric acid, that story is a super precise, massive industrial method called the contact process. This whole thing unfolds in 4 critical steps. You can think of it like a carefully orchestrated industrial symphony, really. It takes us from a simple gas all the way to the final, super powerful acid. The process kicks off by making sulfur dioxide. Now, you can do this just by burning pure sulfur in the air, but on a huge industrial scale, they usually do it by roasting a mineral called iron pyrites with a ton of extra oxygen. Okay, this next part is a real balancing act. To turn that sulfur dioxide into sulfur trioxide, everything has to be just right. You need a special catalyst, vanadium pentoxide, to speed things up, but the temperature? That is absolutely crucial. You see, around 450 degrees Celsius is the sweet spot. It's hot enough to make the reaction happen fast, but if you go any hotter, the product you want starts to break back down. It's all about maximizing that yield. Now you're probably thinking, okay, I've got my sulfur trioxide, now I just add water, right? Whoa. No, that would be a huge mistake. The reaction is so intense, so violently exothermic, that it creates this dangerous, uncontrollable fog of acid that's nearly impossible to collect. So to get around that, industry uses this really clever 2-step trick. First, they dissolve the sulfur trioxide gas in sulfuric acid that's already been made. This creates something called oleum. Then, they can take that oleum and safely, and much more controllably, add water to it to make even more pure sulfuric acid. Pretty smart, huh? Now that we know how it's made, let's look at its character. And this is where it gets really interesting because sulfuric acid has a kind of split personality. It behaves completely differently depending on one simple thing: how much water it's mixed with. And this really shows you the two faces of the king perfectly. When it's dilute, it's a predictable, typical strong acid. But when it's concentrated, it becomes this formidable agent with all these unique, powerful abilities. And get this, the dilute form is a great electrical conductor because of all the free ions floating around, while the concentrated form is actually a poor one. In its dilute form, it just plays by the rules. It does exactly what you'd expect a strong acid to do from your high school chemistry class. It reacts with active metals to give off hydrogen gas, it neutralizes bases to make a salt and water, and it fizzes with carbonates to produce carbon dioxide. Standard stuff. But it's the concentrated form where sulfuric acid truly earns its crown. This is where it wields 3 extraordinary powers that really set it apart from almost any other chemical out there. Its first power is an incredible, almost insatiable thirst for water. I mean, it has such a strong affinity for H₂O that it can physically rip the hydrogen and oxygen atoms, the very elements of water, right out of the molecular structure of other substances. You can see this power in some really dramatic ways. When you add it to sugar, it tears the water right out of the sugar molecules, leaving behind this growing, steaming black pillar of pure carbon. Or look at these beautiful blue copper sulfate crystals. The acid just strips away their water of crystallization, and they turn from blue to just a plain white powder. That's dehydration in action. Okay, power number 2. It's a strong oxidizing agent. Now, what that means is that it's really good at forcefully taking electrons away from other elements, which fundamentally changes their nature. And this power gets even stronger when the acid is hot. It's powerful enough to oxidize a nonmetal like carbon, and it can even attack less reactive metals like copper, which, remember, won't react with the dilute acid at all. But the hot, concentrated stuff, it goes right after it, producing a salt, water, and that pungent sulfur dioxide gas. And that brings us to its third and final power, its stability. With a super high boiling point of 338 degrees Celsius, it doesn't evaporate easily. In chemistry terms, we call that being non-volatile. So why is that a superpower? Well, it's a really clever trick used in labs. You can heat concentrated sulfuric acid with a salt, like sodium chloride, and because the sulfuric acid stays put as a liquid, it can kick out the other more volatile acid as a gas, which you can then easily collect. It's how you can make other important acids like hydrochloric and nitric acid. So we've seen how it's made, we've seen its incredible chemistry, and that brings us right back to the original question. Why does this stuff reign as the king of chemicals?
Well, the answer lies in its absolutely vast kingdom of applications. Look at this chart. A staggering 50% of it goes into making fertilizers. Without it, we simply could not feed the world's population. But then look at the rest. It's a critical ingredient for making other chemicals, it's used for processing metals and ores, and yep, it's the electrolyte in most car batteries.
Bottom line, there is no other manufactured chemical that is used by so many key industries on such a massive scale. Its production level is often seen as a direct indicator of a nation's industrial strength, which makes it, arguably, the single most important chemical in our global economy.
From its fiery creation to its unique powers, sulfuric acid is a true chemical monarch. Its reign has built much of our modern world. But its story also leaves us with a critical question. As we continue to rely on this powerful and hazardous king, how do we make sure we manage its reign safely?